Welcome back to the YouTube channel Civil Engineer, Apex YouTube channel all over the world. Now we are in this session of structural design part, and we discussed about the section classifications, type of loads and type of elements, type of supports. So today we are going to further discuss about principles of superpositions and determinacy of stability and so on. Let's start the session now. The principle of superposition. This principle forms the basis of much of the theory of structural analysis. The total displacement or internal loading can be stress at a point in a structure subjected to several external loadings can be determined by adding together the displacement or internal loadings or stresses caused by each of the external loading acting separately. This is a kind of thing, you have a big meal with rice and fruits and snacks. So you can eat them together in one time. Also you can eat rice first, then fruits, then thirdly the snacks. So this is kind of superpositions. The entire thing can be idealized by two types. So to be valid the principle of superposition, the material must behave in linear elastic manner. And also the second one is the geometry of the structure must not undergo significant change when loads are applied. So that means displacements are small. That is the principle of superposition. For that principle we use equations of equilibrium. Equilibrium is stability. For coplanar structures, equations of equilibrium can be written as sigma fx is 0 and sigma fy is 0 and sigma m is 0. What is this? The forces in x directions, the sigma represents the total forces in x direction should be 0 for equilibrium. So these are for equilibrium, so it means doesn't move. And also in y direction also sigma f, it means total forces in y direction should be 0, and sigma m means total moments should be 0. There can be moment, but when you add or when you connect them, those all moments, the sum, or we can't say sum, it's a kind of vector sum, so it should be 0. So these three equations must be satisfied in order to become a structure or point equilibrium. So whenever these equations are applied, it is first necessary to draw a free body diagram, FBD. We call it FBD, free body diagram of the structure, part of it of member. What is the determinacy and stability? We can discuss this here. I'll zoom a bit. Right. So determinacy and stability. When all the forces in a structure can be determined from equations of equilibrium above, the structure is referred to as statically determinate, SD, statically determinate. Structures having more unknown forces than available equations of equilibrium are called statically indeterminate, SI. So we can't determine statically, but this type of things we can determine, yes. For coplanar structures, there are at most 3 equations of equilibrium for each part, so that if there are n parts and r forces, we say n parts and r number of forces. If r is equal to 3n, that is statically determined. If r is larger than 3n, that is statically indeterminate. If r is less than 3n, that is unstable. It can't exist like that. So this 3n, because 3 use is because we have 3 equations. So these 3 conditions is very crucial for the calculations and all that. And we have an example here. This is example idealized structure. We have a pin joint and we have a roller support here. We have the element, and here n is 1, but r is 3. R3 means we have 3 equations to solve. So r is 3, n is equal to 1, and this is the free body diagram. Here you have two, because this is a pin joint, you have vertical load and horizontal load. This is a roller support, so you only have vertical reaction, so these 2 reactions, and you have 3 unknown terms. So r is equal to 3n, so this is this can be statically determined, so SD type of structure. And when we go to, and also in this example, this certain example, here we have 2 elements. Number of elements is 2, n is equal to 2, and when we realize about the number of reactions, here we have 2 reactions, here you have 2 reactions, and here you have 2, but these 2 are similar, the same point horizontal forces, and here you have 2 reactions. So you have all together 1, 2, 3, 4, 5, 6, 7 reactions are there. Number of elements is 2. When 3 into n is 6, but 6 is less than 7, so r is larger than 3n, so this structure is statically indeterminate according to the theory which I have said earlier. So this structure is statically indeterminate. So this type of examples can be worked out, and now we can shift to the major part. Here is today analysis of trusses. Now this is about trusses, analysis of first structural determinant trusses. We are going to discuss about structurally determinant trusses. So what is a truss? First we need to identify that. Truss is a structure composed of slender members joined together at their endpoints. The members commonly used in construction consist of wooden struts, metal bars, angles, and channels. Metal bars can be circular, hollow, or whatever it is. Angles are these type of steel things, and channels means you have C channels, and you can have another type of channel with this small part we call lipped channels. So these type of elements can be there in trusses. So joints are usually formed by welding or bolting ends of members to a common plate called gusset plate. So trusses usually lie in a single plane and often used to support roofs and bridges. I can see a gusset plate now here. In this figure you can see kind of I section, I section, and another I section is coming, and another section is coming. In this joint a gusset plate has put and connected by bolting. Now this is a section of this one. Actually these are not I section, these are L angles. You have one L angle here, in another L angle. In between you place gusset plate, and by bolts you can join these 2 or 1 bolt or like that. So that is the gusset plate. So here you have a roof truss. We'll discuss about this, right? Here in this truss the roof angle theta is called the angle. It can be either 10 degrees, 20 degrees, 18 degrees, 15 degrees, or whatever it is, but it should be a kind of practicable degree. So we call pitch of the roof or pitch of the truss. And truss is made by elements which I said earlier, and this top one is called top chord and bottom one is called bottom chord, and these are supports, and this entire distance is called span. So on the top of the truss you can have purlins. They can be C purlins or wooden or whatever it is, C or whatever purlins. On the top of the purlins, in the other direction you put roof cover. So this is a joint which come in a chord here, another chord here, and the main chord, bottom chord is going there. So this joint is highly exaggerated as detailed here, which I will explain earlier was that joint. So this joint is formed by bolting. You can do welding either. So this is a fink truss. We call it a fink truss. It has a kind of identical shape. So you have a big triangle in the middle, and triangle type of things are connected like this. Two supports. A fink truss. Another fink truss is this one. You can horizontally cast the trusses. You can have triangles like this in this direction. You have two supports. This is a fink truss. So this is called bowstring. Actually it's like a bow string of the bow. These kind of trusses also can be formed. This can be actually, if you use a cord, you can take it circular, or it can be straight like this, ting 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 like this. So these 2 points are the supports, and we have to make some assumptions when analyzing and designing. So what are the assumptions? There are two important assumptions to idealize the trusses. The first one is members are joined together by smooth pins. It can be definitely considered. And the second one is all loadings are applied at joints, only at joints. Because of these two assumptions, each truss member acts as axial force member. That means tensile law, compression. In general, the compression members must be made thicker than tension members to prevent buckling or sudden instability. So if we consider the section of the member, if it's larger, it can resist the compression more. If it's small, when you compress the section, the entire section could be lead to buckle, right? Buckling. So in order to avoid the buckling, the section should be much larger. It will be very good for. And this is another truss. See here, you have a smooth pin joint here, two supports. Determining, now you need to study about the determinacy and stability. For any problem in truss analysis, the total number of unknowns are B plus R. What is this B plus R? B is the number of bars and R is the number of external reactions. So total number of unknowns are B plus R, number of bars plus number of external reactions. Therefore, the total number of equations are 2J. What is J? J is number of joints. So number of joint is into 2. So this is the total number of the total number of equations. Total number of equations is 2J. Total number of unknowns are B plus R. So if B plus R is equal to 2J, we call it statically determinant. It can be determined. If the B plus R is larger than 2J, it is statically indeterminate. Also, statically indeterminate is equal to B plus R minus 2J. Further, B plus J is less than 2J. We call it unstable. It's a theory. Now we can shift to some examples. Here you have this example of truss 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, you have 13 members. So B is 30, number of bars is 30. R is number of external reactions. You have a roll support here. So unknown is this reaction. No reaction in horizontal direction. You have pin support, so you have 2 reactions. So number of reaction is 3. So what is J? J is number of joints. How many joints do you have? 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 joints. J is 8. According to the theory which I have said earlier, B plus R is 16. 2J is 16. So those two are equal. That means, what is it? If those two are equal, statically determinate. That means the reactions, this problem can be solved easily. So that's it. So what will happen if I put another member like this to the same structure? Let's see it. B number of bars is now 14. Now reactions is still 30. 3. J means number of joints. There are 8 joints. Now you have 8 joints. So B plus R is 17. 2J is 16. So B plus R is more than 2J. So that means it is statically indeterminate. So you cannot solve this problem. So usually people don't put like this in trusses. And when we consider the same problem here, say we have another support here, we are additionally put another support here, another roller support, then we will have another additional reaction here. So number of reactions will become 4, but the number of members it is 30, joints 8. So B plus R is more than 2J. Now that means again the structure is statically indeterminate. So see, the same structure, same truss was previously statically determinate, and when you do some changes like this, add in a member or add in a support, the same structure became statically indeterminate. And this one here, what you have done, you have removed this support. This previously support was removed. Now you have B is 12. Now B means number of bars. Now you have 12, not 30. Reaction is still same, 1 here, 2 here, 3. So joints is 8. B plus R 15. 2J is 16. So B plus R is less than 2J. That means this structure is unstable. This particular structure is unstable. That means this can't be like this here. This will fail down. You can't form in this version. So we can discuss about the 3D truss analysis too. So there are 4 main approaches. First one is graphical method, and the joint method, and method of sections, and equivalent beam method. So for equivalent beam method we use flat trusses, and mainly for flat trusses. So we have some examples, 3D trusses. So this is a kind of huge example. You have 2 supports here, you have 2 reactions here, 1 reaction here in this roller support. So many weights were hanged in these places, and you have this type of members. So here number of members 25, number of reactions unknown, you have 3. Now 2J is 28, B plus R is 28. So those 2 are equal. You can solve this. That means the problem is statically determinate. So you can find the answer solved with the equilibrium theories. Previously I said in my 3rd video, you can find these reactions very easily. So this is how you need to work out with the 3D trusses and all that. In our next video we are going to discuss about analysis of arches and cables. Until then, hang with us, subscribe and share for knowledge always. Thank you, good luck.